I thought my Datsun brethren out there would get a kick out of this. This is a factory bottle jack out of a Datsun 521. So what I'm doing is I'm coming up here just enough to put some pressure on there. That way, as I start drilling in that stuff, I don't move it in the vise. I probably should have done that yesterday when I was doing all the rest of the cutting and that stuff. I could have probably done it a little bit faster, but it didn't dawn on me till today that the bottle jack would work perfect. So let's just go ahead and just pull this in. Okay, so, and I have no clue if it's focused or not. I can't see on the little screen. Anyway, what I'm doing, I've got a 1/4 inch spotting drill in here. Now I measured these reinforcement webs on the casting here. Okay, I measured inside and I measured outside. And I took that difference, 0.88, subtracted it, divided it in half, 0.44. And then what I did was I took half of the outside dimension and subtracted 0.44, and took half of the inside dimension and added 0.44. What I came up with all the way around was 2 inches. So what that's telling me is the center, just like finding the center of 2 holes, like I've shown before, though that webbing is 2 inches apart. So I already used the centering drill and did that trick to find center here, you know, where it slips in and out of there real slick, quick and easy. And just as a double check here, I'm going to take this with 2 inches here and I'm going to hold it up there. Yeah, 2 inches looks like it's exactly in the center. Perfect. Okay, so I'm going to go ahead and just come out 1 inch this way and 1 inch this way. I know 1 inch centers it on the web perfectly, and 1 inch looks to be a nice area here too. So I'm just going to do one by one. So they are going to be in a square, and I'm just going to drill 4 holes on a 2 inch square basically. Okay, so I've got it set at 1 inch and 1 inch. This is a spotting drill. I'm not going to try to drill all the way in there. I'm just going to put a mark in there. Suppose I could drill, but basically this will get my starter hole nice and accurate. And then I'm going to have to do something a little creative here, because this drill chuck, this is all the higher the head goes, and I can't get this any lower, so we'll play with that in a minute. Done is I've moved it over. The DRO will put me right back where I was, since I know all my dimensions and that stuff. Oh, good God. Okay, actually, before I finish taking that out, this is a keyless chuck, but there's 4 round little holes in here, and so I've got a little dowel here, more or less steel dowel, and what I can do is use that as extra leverage to get that tight or loose, as in this case, but I did use it to make it extra tight. So with this particular drill chuck, the threads in the back, in the what do you call it, in the R8 collet. Ow! Oh, good thing that didn't land on me. Anyway, I have to change the drawbar, because it's 2 different threads. And if I was taller or used a step stool, I probably wouldn't have dropped that. Now what I'm going to do here is, I'm using I'm going to see if this will work first. I need a 1/4 inch drill bit as my hole for the 5/16 by 18 bolts I'm putting in, that are the threads that I'm going to make. So what I'm going to do is I'm going to put in a 1/4 inch collet instead of a drill chuck. And as you can see, that buys me an extra, 4 inches. Oh wait, this is a 17/64 drill bit. I gotta find the 1/4 inch drill bit first. So let's go do that. All right, hopefully the fan's not too loud in the background. It's too warm outside to open the shop up, and there's not enough breeze to counteract the heat. So anyway, okay, I put a 1/4 inch collet in here. Okay, now when you do this, you're going to need a drill the same size as your collet. So this is a 1/4 inch drill. That's what I need for my that's the size for tapping. Actually, 0.256 or something like that is the correct size for the 5/16. I'd have to go look at it again. It's certainly close enough. I can always open these up just a little bit more later, but I'm going to do the primary drilling with a 1/4 inch drill bit. Now, what you want to do is, how when you get a drill and a bit and it slips in your chuck and you get that wad of metal. This one even has one way down here, but I think it's been filed off before. That needs to be cleaned off with a file or a grinding stone or something before you try to clamp it down in a collet. Okay, it works with the drill chuck because the drill chuck has just 3 fingers, 3 little contact points. So you can line it up in between them there and clamp it down. Collet, that won't work. So the collet's nice and round and smooth and hardened, and the last thing you want to do is have that drill bit wobble or slip inside the collet and screw up your collet. So the other thing I'm going to do here is I'm going to come down here and I'm going to turn on my Z-axis and get a reference point there for 0 while I'm thinking about it. Now, I shot another video thinking, okay, I don't have enough tap here and everything like that, and it dawned on me, okay, I'm going to take these 5/16 by 18 Allen head bolts, and I'm going to use Allen head so I don't have to drill a big ass hole in here to be able to fit a socket over a bolt. Okay, that way I can drill one just nice and close and keep a lot more meat around the hole. They are going to be counterbored. They're going to go down to here. Now I can cut this. I can cut good 1/4 inch, 3/8 of an inch off this bolt if I need to. Okay, but what the reality is I don't know how well you can. Let me zoom in here a little bit. What the heck? Yeah. Hopefully that'll focus. Never can tell with this dang camera. Bought a nice fancy camera thinking I'd come out here and shoot the videos with it, but then I looked at my gloves and I'm like, I'm not touching my nice camera with these gloves. Okay, so this is where the bolt's going to mount, more or less flush with this. Okay, I need the tap to extend 3/8 of an inch below the head here because there's no threads out here on the end of this spiral point. There's no threads, for the bottom of the hole. Okay, so just eyeballing it here, I hold it there. Well, now this plate will come off when I do the tapping. Okay, so if I hold the bolt there and hold that down to where the end of the threads are and that stuff, I don't know if you can see that or not, but that basically gives me about 3/8 of an inch of tap down past the bolt. So that really ought to work okay. Shouldn't have to get too creative or fancy with that. So basically I'm just going to drill one here and the other thing I wanted to do was to get a measurement here while I'm here. Okay, so let's just kind of hold the tap. That's as far as the tap's going to go down, and it's 2 inches to the tip. So I want to go at least 2 inches in. So my Z-axis is zeroed out. I'm going to end up going up the drill bit about this far. Hopefully the quill on this has enough travel to do that. We'll find out here. So it clears out the chips and that stuff on the end there. I need to go get some coolant because that's going to get pretty hot. And, I want to do the cast iron Yeah, I may drill it separately. I at least got to get through there first. And the battery. Now, something else I did here too is just as double check, and it's really a good idea with the using the drill chuck. The collet grabs on pretty dang tight. But what I did was, since I knew that I set 0 right there at the top, when I finished with each hole, I went ahead and just held the drill bit there and looked up my Z-axis and made sure that it was still at 0. Okay, that way I knew that I didn't push the drill bit up inside the collet and end up drilling a extra short hole. So it looks like I'm still okay there. So just a little thing to watch out for there. And I knew when I was through the steel here, because you know, the steel gives off chips like this. The once you get into the cast iron, it's like powder, and it's annoying. It goes everywhere. It's in my ears. All right, next up, I put a 5/16 drill bit in here, and a 5/16 collet. Same kind of reasons as with the 1/4 inch. Now I measured the thickness of this. This is 0.584, somewhere around there. So I need to go basically 0.585 down. So I have taken my quill down, zeroed out my Z-axis, and now when I drill, I'll watch my Z-axis. I'll go down to 0.585, and that's it. And then I know that I'm through the steel and not into the cast iron. After that, then we'll do the counterbore. I'm doing the pass-through hole first because that leaves me, since I'm going to have to do the counterbore with an end mill, the less metal I have to remove with the end mill, the easier it is on the end mill. So I'm going to remove more metal with the drill bit first, then come in with the end mill. I could have done it either way, but this just makes it easier on the end mill. Okay, this is getting close to the end here. Thank God. Okay, I got the Allen head here. Like I said before, I want to counterbore this. I've got a 1/2 inch end mill in here, 4 flute. That will that'll cut nicely, and it'll leave me a flat bottomed hole as opposed to leaving a tapered hole if I were to do that with a drill bit. Okay. The other thing is here is I measured this with the calipers, and it's 0.312 roughly, and I want to make sure I go at least that, so 0.325 would be fine. So I can zero out my Z-axis there and cut down to that. Now if I didn't have the caliper, or I was being lazy or whatever, I could just come down here and do this and measure that, 0.307. That gave me a quick reading without having to go dig out the calipers and that stuff. So now I can say, okay, I want to go just a hair over that, and you know, just say 0.320, 0.325, anywhere in there to call it good. I just want to try to make them each pretty close to the same. And if I wanted to get really accurate, instead of using the plunge with the arm, I could turn on the wheel, you know, the hand wheel kind of thing. I'm going to do the first one with the hand and see how close I can get it. And if I get it close enough, nobody's ever going to see this. If it's not perfect, it doesn't matter. Alright, that looked like it went down about 0.327. Close enough. I'm going to go ahead and do the other 4, and we should be good to go. Alright, let's see here. Yep, that just recesses. I might actually want to go just a hair more, just because, but not a whole lot more. Alright, there's a bunch of shake and wiggle going on around here and stuff like that. It wasn't pretty, but they're done. So they're all within a few thousandths of each other there. Now they're pretty darn tight. The 5/16 hole there is pretty darn tight on this Allen. So basically what I'm going to do is, since I don't really have room for the drill chuck in here and the drill, blah blah blah, to clearance those out, that's going to be just the next drill bit bigger, take very little metal off kind of thing. I can do that in the vise, on the drill press, anything like that. I don't really have to, I don't need the mill for that. So I'm going to unclamp this and take this piece off and get it set up for doing the tapping. And we'll do the tapping while it's in here, because that'll, I could do it by power, but it's cast iron, and we'll just do a tiny note here. I figured out at some point this hole here got shifted a little bit. So I kind of doubt this thing is going to go on in either direction. So I'm going to go ahead and just put a little dot right here so that I can line this up and know which way it faces next time. I'm also going to put this back in the lathe now that I see just how much smaller this is. I'm going to put it back in the lathe and put a bevel on there that takes it roughly down to that dimension, just to make it look better. All right, I'll show you this real quick. Can you see that? Maybe. That's about all. That's all the further in it goes. Okay, this hole, there's a little bit of a dimple right here. Okay, these do not have dimples, and that's from when I was drilling the 5/16 pass-through hole. It went through just a little bit far. Okay, no big deal. That's fine. It left me a little taper here. Okay, so this hole is fully drilled. That's the one that was over that. These 3 holes aren't quite all the way through, which is fine for this. It would have been okay if I put a little bevel on there. That just would have made it easier to start to tap. But this will get cleaned up when I do the next size bigger than 5/16, 11/32, something like that. Actually, it's probably a 64th. Anyway, so that was the thing. Had I been a little bit more accurate there with things, each one of them would have had a dimple, or none of them would have had a dimple. Well, it looks like I'm going to have to hand tap them here. I was hoping to get in here and tap them while it was still in the mill. I have a tap guide right here, but that has to go up under there. I don't even have enough room here for it, so I'm going to take it off, and I'll just have to carefully tap them by hand. I can move it over. I can actually leave it clamped in the vise and just move it over here a bit and do that. That'll make it a little easier. I won't have to try to hold this, and there's no point in moving it to the bench vise just to do the exact same thing. So, all right, well, this ought to be an adventure. Okay, I moved it over here. I could have gone the other way. I've already double checked that I have enough vertical clearance for the tools and that stuff for tapping. Okay, I've taken my air nozzle, gone down in here, and cleaned all the chips out of there, and there was a ton. What I'm going to do here real quick is I'm going to just put an Allen wrench down there and get a depth check, and I'm really, really close there. So the next thing I want to see is, compared to when I run out of threads there, okay, I still have quite a bit of room at the end of that hole there. So that's what I want to see. Now I got 2 different methods set up here. We'll try, but first let's, I got the countersink here. I'm just going to go ahead and put a little countersink on each one here, so that to help the tap get started. That way it doesn't have to try to get in on that really hard edge there. Now I got the drill here with the tap adapter set up. I'm going to try to run at least 1, if not 2 in with that. Now I know you're supposed to cut cast iron dry. Whether that includes tapping or not, I don't know. We'll see how bad this binds up and decide at that point. So I'm basically going to try to hold this thing as straight as I can. Kind of brace myself against the mill here. Oh, somebody, the chuck or the clutch was slipping there. Now that's cutting pretty nice. I'm going to go ahead and back out just a hair to break any chips off. And all of the chips are going down into that recess. That's part of the reason why I drilled that hole extra deep. Ooh, see that bind up there? Oh, that's not good. There we go. Got a big ass chip there that had to break off. Okay, we'll call that good. That's should be all the deeper I needed anyway. Now I'm lifting up on the drill just to, that way when it reaches the end of travel coming up, it pops right up out of there instead of riding on there and just going thump 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 thump. So it's blow it out. Oh man. Feel all that crap just blowing up out of there. Ooh, that threads in nice and pretty, doesn't it? Okay, so that's about where the threads bottom out. So we're just going to take a quick glance here. Now we know that this head just barely seats below that, so I got at least a 1/16 of an inch there before the threads bottom out. So I'm quite happy with that. Now I know I can run the tap all the way to the bottom of the threads and be good to go. Now the other method I'm going to try here, and I've used this before too, this is the 3/8 impact. We're going to run it down and see which one we like better. The drill, you can tell from the torque, it got a little tight there, so Alright, cool. You know, actually the second one there actually went in a little nicer. Certainly easier on me trying to hold it. Oh. Should probably put your hand around there when you do that, because that shit all comes up and blasts your arm. So anyway, I'm going to do the other two, and that should be good. Okay. Getting real close to the end here. Got a little burr around there. Let's just see if we can give it a little I'll walk it around there just a hair. Try to keep them somewhat uniform. But you know, the reality is, as I've mentioned several times, you're just not going to see that part. Okay, this is a 21/64. It's one size bigger than 5/16. Now, if you get into the letters and stuff like that, you might find one that's in between these two, but this is certainly close enough. So, wow. It's not that hard. I just have I just pulled this battery out of the charger, so apparently this is one of the NiCads. It's damn near dead. So, oh yeah, much better. Okay, next we'll stick this. I'm going to flip it over. I'm going to hit the backside with the countersink. There's a little burr back there. And then I'm going to mount it up on the milling attachment and see how I like it. Of course, I didn't change batteries first, but we hit it with the countersink. Now I put these, the guy I got the vise off of, Andrew Drummond, used to be a 521 guy. He made these little aluminum jaw covers, so that keeps me from marring up my nice steel. Not that my surface finish is all that beautiful, but still keeps it from getting jaw marks. And yes, my countersink is getting quite dull. That's why I've got to walk it around to take the burr off. So that's pretty. Let's put on the truth here. Will all four of them go back in and line back up nicely? They should. They were all drilled together. That was the point of drilling them together. Look at that. All right. So let's just throw them down. I don't have to crank them down or anything like that. I'm gonna take it back off and put it right back on the lathe to cut that bevel, and then it'll be done. Still got a little debris on that bolt or that or in the threads there. So just snug them up a bit. Man, actually, let's see here. Let's crack them loose. Most of the, oh, look at that. Oh, that's a thing of beauty. All right. So, I got them seated down. Let's, seeing if there's any burrs still sticking up around the holes, taking those off basically, and I'm not hitting the bolt heads, so they're down in there enough. Oh yeah, they're recessed in there perfectly. 32nd of an inch maybe. Oh, not good to drop your taps on the concrete there. Don't do that. Okay, onto the lathe. I forgot one thing here. This spins extremely true in here. Now, I could measure the milling attachment and then figure out the taper, blah, 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 all that kind of stuff. What I'm going to do, though, is I'm going to take the carbide scribe here, and I'm just going to do that. Now, I have myself a shiny little mark all the way around there. So what I can do is I can just now go onto the lathe and cut until I get to that, or get close. And that saved me a whole ton of grief with trying to figure it out in mathematics and that kind of crap. Okay, as my proof of not being too bright today, I got all excited about cutting that bevel down to match the milling attachment. And as I was making the very last final pass, I heard this, and what it was is it was just squeezing away at the corner of the hole here. So that kind of sucks actually, but what I may do is I may take a couple of face cuts off of here, take it down a little bit just to get myself a little shelf there. I'll just pull this pin out, and I think that's what I'm going to do, because yeah, I should have made that half of what it is. That would have left me 1/8 of an inch out there and would have been good to go. Oh well, don't have to be too bright to be me. All right, well, here we go. First time going on. Everything should fit. I've got it, oh, man, look at that. That'll be all right. I didn't need, oops. There's a slot down there where they come out the bottom, so you don't want to turn it there. Oh. Still got a little bit more to go. Remember I said I was taking what do you call it? I locked it down. I shaved it down flat, so I got a little bit of a flat spot there around the hole. So there's just a little shoulder there, which is good enough. And couldn't find it. Oh, ouch, ouch, ouch! Couldn't find the stupid bolt nut. Anyway. About the only other thing that I think I got left to do on this, and look at how friggin' nice and smooth that is. Oh my god, that is just friggin', and I don't even have it tightened down yet, man. This is beautiful. Oh god. That's one of the coolest friggin' things about having these tools, is taking that big ass chunk of friggin' square plate and, you know, making that piece, making this work. That's by far my favorite thing. And the cars just simply give me an excuse to do stuff. So if I wasn't doing the upper control arms and needing to notch tubing, I wouldn't, you know, I wouldn't have bothered getting this, following through with this, all that kind of crap. So the only other thing I need to do now is I want to take and put this up against the face, get it square, and then I'm going to mark a line there on my new adapter, so that then I can be able to turn it and say, okay, that's 45 degrees. That's basically all I got left. So I think I'll get on that. And, oh, I might call it a day, man. I'm beat. This is too much work. All right, I figured I'd show this too. Now, I could reference against this or the top jaw, but I'm not absolutely positive those are perfectly flat and parallel with the bottom of the jaw here. Now, the bottom of the jaw, whenever I put something in there, most likely I'm going to be registering hard up against that. So I want to go ahead and put this 1, 2, 3 block in here. And they don't need to be held tight or anything like that, because I'm going to be pushing against the jaw. So then I'm going to come down here, and basically I'm just going to push against the jaw there, and then tighten these up. And the plate that's in there is the saddle lifting up slightly, the cross side lifting up. So I was just reading today that you know, these are only good for oh, it was a video by Tubal Cain. It's got some great stuff on YouTube. Anyway, he said these are only for light cuts and stuff like that. So as you can see, you know, there is still some play in there. So now that I am squared up there, I can make my mark. So let's figure out exactly how I want to do that. Let's see here if I can do this. Now, I showed this once before, where I took the scribe, came down here, and basically just walked it up. Let's see here. Let's give me a little mark. It did give me a mark. Okay, now what I'm going to try here is I took this chisel and I sharpened it so that it's slightly skewed like this. Okay, so that gives me a chance to tilt it up just a hair. It also means that with this thing in the way here, I can actually get it straight on or at a little bit of an angle there. So let's see if I can get this darn thing where I want it, right on which line 0 there. Need another hand around here. Sheesh. Need more light. Oh man. Okay, so that's touching. Let's see if I can get it straight up and down here. Oh man, moving all over the place. Well, I think that's it. Let's try it. Now, I just wanted a light mark there. Because I don't want it to stick it back on the lathe to turn it back down. Oh yeah, right on the money. Okay, and it went all the way up. Now, I should be able to find that dimple again. And get it, yep, see that? Get it lined back up in that same chisel mark. And give it a little bit more stout. Yeah, beautiful. Oh yeah. So, I need to kind of come in here at a bit of an angle because tilt it down a hair because I want the bottom nice and pronounced too. And even though I you know, cut it at a slight angle like that, it's just barely getting in there. Yeah, nice. Okay, that was probably a little. I lost my hammer. It's probably a little tedious and boring to watch on the video. Oh, 3.5 minutes. Wow. So I tried to hold it still there, but I think you can see there that's lined up nice. I got a good proud mark. Well defined, easy to see, certainly a whole lot better than the one that's on the compound. So I think I am done. Wow, maybe? Well, with all that planning and everything, I got it to fit the socket, but I can't put my wrench in here. So I'll either need to trim the wrench down a little bit or pull this back apart and grind those, cut those open just a little bit more. I think for now I'm just going to use a socket and move on.